Alright, I wanted to do a Taylor series that's kind of cool and lets us explore a shortcut that's available. At the end of my handout, I asked you to find the Taylor series for f of x equals 3 over 1 minus x squared. And there's maybe a hint, but I didn't give you all of the secrets with that single lesson on Taylor series. So this kind of lets you see one of those potential secrets in action. So here we go. One thing is to first think of this as 3 times this. Think of the 3 as a constant. Constants are nice. And then, although we don't know the series for this, just kind of keep in mind that it kind of looks like this. And this is one of the series that I said is important, and it kind of shows up. And remember that the Taylor approximation for this is the series 1 plus x squared plus x cubed. Again, as far as you want to go. And so the series that we're trying to find is really similar to this one that I just wrote, except instead of an x, it's an x cubed. And so if you try to do this series by hand, which I know a few of you did because I got some emails, the derivatives, meaning f prime of x, f double prime of x, and beyond, they become increasingly difficult, and they become kind of a big pain in the butt. And if you actually find f prime of 0, it equals 0. And if you find f double prime of 0, it also equals 0. And if you had the patience to actually find f triple prime, it wouldn't equal 0. And so the series does exist, but there's a quick way to get it. So without further ado, think of this as an argument, meaning something that's replaceable. And that x is the same as this. Don't think of it as x, think of it as an argument. Which means that the only thing that really changed in here is instead of x, it's now an x cubed. And so what I mean is I can rewrite this as the series 3 times 1 plus the argument squared plus the argument cubed plus however far I want to go. But the one that we memorized, or the ones that we studied, the argument was x, and so all these were x's. But now the argument, the thing that's replacing the x, is x cubed, which is wild. Because my claim is, and it's a true claim, is that the Taylor series for this is 3 times 1 plus x cubed plus x to the 6th plus x to the 9th, dot, dot, dot. Or you could write this as 3 plus 3x cubed plus 3x to the 6th. You guys see the pattern? It's pretty awesome. Plus dot, dot, dot. And so sometimes you can identify this as in sigma notation. As n goes from 0 to infinity. The first term would be 3 x to the 0th power. But I could also represent it as 3n. This takes a little practice. We haven't talked too much about this yet, but one thing you could think of is these numbers are all multiples of 3. So I can represent that pattern with the 3n. The constants along for the ride, if you plug in 0, it's to the 0th power. If you plug in 1, it gives you a 3. If you plug in 2, it gives you a 6, and so on and so forth. So this is the series, and here it is represented with sigma notation. Things to think about. Thanks for watching.